See if people are coming. Finally figured out. Yay, look at that. The numbers are going up. I like when the numbers go up. Yay, people are coming, are here. All right. How many people are watching? Got 13. We're gonna give it like maybe a couple more minutes for people to come in. I will say I'm sorry for the incredible delay. Turns out the broadcasting software just kind of broke with the upgrade to the new version of Mac OS, and so I had to find a workaround. So here I am. I feel like I just should put out a blast on Piazza. Say, hey, I'm live. Don't want to spam everybody though. Is it? Let's turn up the volume. How does that work? Does that sound better? Nice. How's that? Should I talk like this? Cool. Okay. We're at 24 people. And so since I've been sitting live for about 5 minutes, I think it's a fine time to get started. Yeah. So the way that this will work is you can just post your questions that you might have in the chat. So there's a little chat bar there. Post any questions that you have, any broad topics that you'd like to discuss. I don't have any formal plan for this, so we'll just kind of go for maybe about an hour, and then just answering questions and going through things. So I don't know if I will just have my terminal and code editor open, and we'll bounce back and forth between here and the visualizer and any other things that we might need to talk about. So does anybody have any questions or anything that they wanted to talk about to get me started? Precedence of and or. Yeah. All right, so far I see precedence of and versus or, the basics of memory management, for loops versus while loops, talk about in statements, aliases. So we got 2 for memory, types of lists, loops. Keep a topics, people, one. Let's do okay. Let's go through. It is coming through. So I'm just making a list of all the things and then tallying up kind of the votes. So I'm going to talk about in keyword. Management. Loops. Statements. Okay, so a couple things that I'll highlight right now. Dot format. If I hop into yeah, so for formatting, you don't have to worry about string formatting for the exam. That's what I wanted to say. Are we handwriting code for the midterm? Yes, you will be handwriting code for the midterm. So there is right around 4 or 5 handwritten coding questions that you'll have to write. They're on the level of lab quiz kind of coding question. So they're not they're not the kind of question where you would get a whole week to think about it and work to do it. They're small and they're meant to test your knowledge of how to use one or two particular constructs. Okay. Is it possible to post solutions? So unfortunately, we don't post solutions for the homeworks or projects. A lot of times, questions will get recycled in some way, shape, or form, and so to have solutions or formal solutions floating on the internet is not great for that. So there's no lab this week. No lab this week because of the midterm. Is there any other like general questions? Otherwise, I'm just gonna kind of go through these topics that people want to talk about, and then I'll go through just the review guide one after another. Nope. Okay, then let's talk about, let's do and versus or. So let me pull up my terminal. Cool. So I'll just, let's find where it is. So, let me pull up the terminal. And make this bigger. So, can we all see the terminal fine on your screen? Yeah? Okay. Then let's talk about and versus or. So I'm just in the interpreter for this. Remember the and statement, right? It takes two expressions that can be evaluated to be a Boolean and performs the and operation. So the and operation essentially says if the two things on either side of the and, right, are true, then the whole statement is true. Otherwise, the whole statement is false. So you can see that if you do true and true, right? This has both sides, they're true, and so the whole statement evaluates to true. And the second you make any part of this false, you're going to get a false back, right? Even if both of them are false, right? So or works a little bit different in that you still has two sides to the statement, but now the requirement is that one of these sides should be true. And once one of these sides are true, then the whole statement is true. And you can have one of those sides of the or be false, and the whole statement is still true. But once you get both false, or two falses together, you get a false at the end. So the question is, what happens when you order them? Okay, when you combine ands and ors together. So the precedence of the and or statement, it should be, let me just come up with a quick example. Let's try, so if we do, let's do 5 is less than 4, or 4, or 5 is bigger than 10. So I write this expression, just a plain old OR, saying 4 is less than 5, that's a true statement, right? ORed with 5 is bigger than 10, that's a false statement. So we have a true ORed with a false, our result is a true. What happens if I throw in and something that's false? So let's do 7 less than 3. Okay. Our result is still true. Okay. The way that precedence works here is that you're going to figure out your should be the and that happens first. Yep. So this happens first, right? And has higher precedence. Okay. Why is it true that this happens first? Well, if it didn't happen first, then the whole thing would be false. Okay. Why is that? Well, the way this is evaluated, we do this and statement first. 5 is bigger than 10. Okay. That is false. ANDed with 7 less than 3. That's also false. So this whole statement right here, this whole piece, condenses into false. Okay, so you have 4 less than 5 or something that's false. So something that's true, ORed with something that's false, is true. What if it was the other way around? What if OR came first? Well, you would do this part first. So something true, ORed with something false, is true. Right? Then you'd have something true, ORed ANDed with something false, which should get you a false, but it doesn't. Okay? And has the higher precedence. Okay? Not is even higher, so it's the nots, and then the ands, and then the ors. Cool. So we did and versus or. Do we need to know terminology for the midterm? Yes, you should be familiar with the definitions of different things. It doesn't necessarily mean that you're going to be asked to regurgitate the definitions of things, but you might be asked about the difference between two concepts or something like that. Okay. Memory management. So let's talk memory. Cool. So. Memory is best explained with the visualizer, I think. Tutor. That or with my handy whiteboard behind me. We'll see. Let's do... let's see if I can just do it on the whiteboard. So, figure out where the window is, and then make this come to the front. No, I'm hiding. Go away. Yeah. So where's mine? I got this. I can do neat. All right. So, what exactly about aliases do we want to talk about? Do you just want a basic rundown, or do you want to talk problems that you might see, the difference between copying and things? Otherwise, I can just start talking. Both basic rundown problems you might see. Cool. So the basic way we start talking about this in lecture is the way that you might see the way you have to draw things out. So if I have a line of code, so I just make x is equals 1, 2, 3. Okay. When I make this list, the way that the memory is represented is similar to the way that a variable is made. Right? So if I make x equals 5, what that does is it goes off into this memory land bubble. Oh, the glare is not good. Might have a, anyway, goes off into this memory space. Okay, figures out, hey, I need to make room to store a value that is going to be called x, and what goes inside the value of the expression on the right hand side of the assignment. So that's what we were used to. When we have a list, it's the same kind of idea, except there's a little more to it. The value on the right hand side is now more than just a single thing. Right? There's 3 things in there. So the first thing that has to happen is we have to make room for these 3 things in a nice sequential space. So we reserve some sequence. Okay. In that sequence goes 1, 2, and 3 right next to each other. Okay. Once we've made the space for the list, now we need a space for the variable. Okay. So somewhere else we have a place for the variable x's inside of this box. Doesn't go the list itself. Okay? We already made room for it somewhere else. We have to tell x's where it is. And so that's where this concept of drawing arrows came into play. Okay? X's stores what we'll call a reference to the list that it actually needs to use. Okay? Lists always exist somewhere outside of the variable that they need. So what happens when I make a copy? Okay, well, there's a couple different ways that you might try to make a copy. Okay, so if I get rid of a little bit of this. Okay. So if we start off with x is equals 1, 2, 3, and then let's say I write y's equals x's. Okay, so what is this saying to do? Okay, this says create a new variable called y's. What is the contents of that variable? Well, whatever the contents of x's is. Okay, this is, remember, if I write something like this, x equals 5, and then y equals x. Nope, that's a little bit too high. Cool. So if I write x equals 5 and then y equals x, what's going on here is somewhere there's a box called x that stores the number 5. And that's what we've already done. Now, when I say y equals x, we apply the same concept. We make some space, call it y, and what do we put in there? Well, we have to evaluate this expression first. We have to figure out what the value of x is. It's 5. So do we copy x entirely into there? Is there any sort of link between these 2 places? No. We take the value, store it inside of this place, and we copy it into that place. So now they both have the number 5, but I can change x, I can change y, and that change won't be felt in either place. Okay. Something different happens with lists. Okay. And by different, I mean what ends up happening is the copy that is made is of this reference. It's of the arrow. And so because we're copying a reference to the same place, what you'll see is any kind of edit you make to x's or y's, right, will be felt in both places. Right? We call those aliases. So in the same vein, right, over here we make a place for y's, right? And what goes inside of this box? Well, we copy whatever information is inside of x's. That information is just the arrow, right? This is the contents of x's. The list itself is not the contents. So we copy the error, right? Went to the same place. And that's why when you do something after you do this, if you were to say take the 0 index of y's and set that equal to 9. Okay. This says go to the 0 index of y's, follow the arrow, go to the very first box right here, change its value to the number 9. Okay. Because both of these variables, x's and y's, refer to the very same list. Regardless of how I change it, that change will be felt in both places. So you can see that. Oops. Okay, if I pull up my thing again. Cool. Okay. Right, if I open up my interpreter and I do what I just did, okay, the x's is equal to 1, 2, 3. Okay, so I can use the handy dandy ID function to tell me where x's is. What is the integer representation of this arrow? Okay, so in this case, it's this number. Right, whatever ends in 0560. When I type y's equals x's, okay, I expect, right, judging by what we just did, that the number here, the number stored in y's, will be exactly the same as x's. And you can prove that to yourself by inspecting the ID of y's. It's the same. Okay, and you can even throw that into an equality statement, right? Is the memory location of x's the same as the memory location of y's? Yep. And so if this doesn't make a true copy, right? If I write y is at 0 equals 9, okay, well, we haven't changed anything about where x's and y's are. But if I look at what y's is, it's 9, 2, 3. And if I look at what x's is, it's 9, 2, 3. The only edit I made was directly to y's, but because x's and y's are aliases of each other, they're in the same memory location, you see that change affect both. So this doesn't do a real copy. Right? How might we do a real copy? Well, there's a couple different ways. Okay? There's the list casting function. So if I take, I can make a real copy by throwing x's into a list, into this list function. Okay. And you can prove to yourself that has made a real copy by throwing the ID function around it. Notice how this number is different from this number. Right? And even throw that into an equality statement to prove that. So what does that mean? Well, I've now made an actual copy of the list. How does that look in memory? There's my eraser. Okay. So instead, there we go. It's bigger. Yeah, that looks good. So I make a real copy. By throwing the list function around x's. There's a couple different ways you can make a copy. Right, this is one of them. X's colon will make a copy of the entire list. And then there's also just plain old x's dot copy. Dot copy. Okay. Lots of different ways to make a copy. The one thing to note is that this is always a single dimension copy. What does that mean? Well, apply the same rules of creating variables. We make a box. That box is named real copy. Right? What goes inside of this box? Well, we've applied the list function to x's. Right? And the same goes for if I do x's with a bracket colon, or if I do x's dot copy. That initiates an actual copy of individual elements into a brand new list. So what we're going to do is the same as if we've written a list outright, like this. So we take all of the items, right, one at a time, and put them into some new place, right, where the first element of this new place is the first element of this in the old place. The next element is the next element from the old place, and the last element is the last element from the old place. Brand new list that happens to have the same things inside because we've made a copy. And so after we've generated the copy of the list, we have to tell real copy where it is. And so we get a new arrow and tell it where to go. And so that's why you see that the IDs are different when I make a copy. So let's just create a copy. Yep, yeah, it makes a copy with a different ID. Oh, hi Julian. Thank you. All right. Cool. So that's what happens when you make a copy. But the this is kind of simple, straightforward, because the data that's inside of these lists is not complex. Right? It's just plain old numbers. And so the tricky part is when you have data that is complex, multiple dimensions, big. What would that look like? Well, first things first, what does a more complex data structure look like if I were to draw it out? Let's, in the chat, somebody type in a two-dimensional list that has 2 rows and 3 columns. Who wants to give me one? Nobody? Or is the latency that bad? There we go. There's one. 1, 2, 3, 4, 5, 6. Good enough. 1, 2, 4, 5, 6, 7. Let's go with that one first. So let's do all the way up here. Or just call it nums for simplicity. So nums is 1, 2, 3, 4, 5, 6. For a two-dimensional list, the rows are the inner lists, right? So one row is one of these inner lists. The columns are the contents of the inner list. Right? So if I were to write this out in a matrix, right, it would look like this. Yeah. So let's do. I'll draw this memory out. That's not cut off too bad, is it? Yeah, it'll be fine. So first things first, you have to say or figure out where the inner lists are. Right? The same way that when you just have a plain old single list, you have to create memory for it. That happens here too. So let's go ahead and say over here we've got a nice little box. It's got 3 things in it, and those things are just 1, 2, and 3. Okay. So we've made this list. Now let's make this list. 4, 5, and 6. Ah, the glare. Ah. Make the glare better. Yeah, I made it better. Okay, cool. So we've got these 2 lists, right? 1, 2, 3, 4, 5, and 6. They each have their own spot in memory. So now we have this outer list. That outer list needs to have space as well. Okay. How many elements are in this outer list? There's 2. Right? There's just this list and this list. So this outer list has 2 things. What are the contents of this? Right? This outer list doesn't store the actual inner list. It just says, where are they? So this is actually a reference to the list containing 1, 2, and 3. And this is also a reference, but to a different list, the one containing 4, 5, and 6. So does this list get a name? Nope. Right? Because this is just another list, right? So we figured out what the memory structure looks like for this more complex piece of data, but now we have to tell it where to begin, right? That's what we give. That's what we make nums for, right? Nums gets a box. It's called nums, and inside goes an arrow pointing to the beginning of the outer list. Cool. And so what happens if I try to make a copy like this? Right? So if I try to make a copy by saying, let's use nums, bracket, colon. Okay, so you follow along. When I open this up and I make my lists, 4, 5, 6, we can first inspect, right, and find out that all the memory is different. Okay, so if I look at the ID of nums, it's in this place. Okay, I expect that this arrow, right, this is the one that we just looked up. I expect this arrow to be different from these 2. Right? How would I access this arrow, this first one? All right. Where is it? It is in the 0 index of nums. And so nums at 0, you see the contents, but if we look at where that list is, nums at 0, it's in a different place. Right? That number is different. Cool. And the same thing for nums at 1. Right? That number is also different. So all these arrows, as we expect by writing nums bracket colon. So this says make a slice subsequence, right, of nums starting at the beginning of this and going into the end of this nums. Okay. So when I hit enter, okay, what do you expect to happen? Well, for starters, we expect that nums, right, nums copy, that should be in a different place, right? That should be a different place from nums. And so if I look at where nums copy is, all right, this number is different from this number. Nums and nums copy are in different places. Right? But what about nums copy at 0? Right? The first list in this copy. Right? It's at this place. Right? And since 0, 3, 5, 2, we have a match. Right? It turns out that the lists themselves were not copied into new memory. Okay? And so, well, why? Right? Well, that's just because the rule hasn't changed for copying lists. Right? When you make a copy, it's the contents of each individual part of the list that gets copied into the new place. And so if the contents happens to be a reference, well, you just copy the arrow. And if you're just copying the arrow, you're not changing anything about where that list is or what it is. Okay, so what does that look like? Okay. This statement, okay, nums copy equals none. This says generate a slice from the beginning to the end of nums. Okay, so that says make a new spot. Right, it has the same size as nums, 2 elements. Copy the contents of each of these places into its respective place in the copy. So we're copying the arrow. Right? So this gets copied, and it goes all the way up here. Right? We're copying the arrow right in there. So that gets copied. Where does it point? 4, 5, and 6. What does that mean in terms of where are the aliases? Okay. Anywhere that in your diagram or when you do check for IDs being the same, anywhere where the ID is the same, where the arrows point to the same place, whatever the source of the arrow is, that is an alias for that memory location. And so right now we have 2 aliases for both of these lists. Right? One is sourced from nums. Right? Nums at 0 is an alias for 1, 2, and 3. One is also sourced from the copy. Right? So we make our copy. Right? The copy at index 0 is the same memory location as 1, 2, and 3. And the copy at index 1 is the same memory location as 4, 5, and 6. Which is for nums 1. Right? You can change the indexes here. You'll see it's still true. Okay? Which is interesting. Right? Because what happens if I make a change to the copy? Okay? So let's take our nums copy and let's add, I don't know, apple, the string apple onto the end of the copy. So what will this do? Well, what we've said is, hey, go to the copy, and at the end of this list, add the string apple. So what changes here? Well, this is the list referenced by the copy, and so we go on the end of this list, and we add the string apple. Just redraw the arrow because I didn't want to draw on top of it. Excuse me. And so apple gets added in right there. Where did, well, if I print out nums, or print nums at 0, print out nums, yeah. If I print out nums, what will I see? Will I see apple in there? No, right? Because there is no relationship between these 2 lists. It's just that the contents of these lists, right, the first 2 contents at least, are the same. By adding something into the copy, I do not affect the original source. But I can affect the original source if I make a change to something that also has an alias to somewhere else. Right? Printing out the copy, I'm going to go ahead, I'm going to see apples. Oops. Other way around. Right? I'm going to see apple because that's what I expect. But let's say we do something like this. nums copy at 0 dot append. Let's put the number 9 in there. Okay, nums copy at 0 dot append 9. So let's, what happens in our diagram? We've said go to the copy at index 0, follow that arrow, and change this first element to be the number 9. Okay. And so in our diagram, we see that, yeah, we've affected the copy, but we've also affected any other aliases of this particular place. Okay. So when I print nums copy, I will see that, oh, oops, I wrote append, but I did something else. Okay. I did change nums copy at 0 to be 9. So what we've done is actually this. Stick the number 9 on the end. Okay, that's what append does. Okay, sorry about that. So we did append the number 9 onto this list. Same thing though, right? We've made a change to this list that is felt by all the aliases. So when I print out nums copy, yeah, cool. I see both the contents of the first thing, that whole list, contents of the second thing, this whole list, and also apple. What happens when I print out just nums by itself? Okay, 1, 2, 3. I still see the 9 being added into that list. Why? Because, well, nums, right, those elements are just aliases for somewhere else. Anything that I do to an alias shows up regardless of what alias I'm referencing later. Cool. So that's aliases. What else am I going to talk about? Problems. Cool. Okay. So that's aliases. Now we'll talk for loops versus while loops, nested loops. So basics of, well, any questions about aliases? Was that run down? That would be a better use of time. Let's look at fires, memory. Questions? Percent. Yeah. Cool. So 6. Do this one. Let me just go in here and capture it. Browser. Oh no, that's wrong. Go away. Okay. Firefox. Yay. Cool. So I'm just going to run through these very quickly. All right. So, for this question, consider the following code. are y's and s's aliases of each other? So for this kind of question, it'll help to sketch what the memory looks like. Okay. So if I go onto my trusty whiteboard, okay, and I have the creation of two lists, x's and y's. Okay, so we've got 1, 2, 3 there. That's x's. Okay, y's, we've got 4, 5, and 6 somewhere else. That's y's. Okay. For both, we've got two elements. The contents here, the first one is x's. So we copy the location from x's, put that in there. For y's, do the same thing. Right? We copy this, and we point that to y's. And now we have r's equals x's. Okay. Remember from just before, when you have that single assignment, you will make out of scope here. You're going to make room for it. Okay. R's equals x's says to copy the arrow from x's, put it into r's, and so that makes x's and r's an alias for each other, alias for the same thing. Okay. S's equal is the copy of y's. Okay, so S's says make a list, slice of y's, put that into a new place. So we're going to go ahead, make a copy somewhere else. Cool. And copy in 4, 5, and 6 in there. Okay. S's points to that new place. So when you're asked this question, are y's and s's aliases, you're essentially saying, do the arrows from y's and s's point to the same place? Y's points here, s's points here, and so y's and s's are not aliases of each other. Okay. And at this point, right, that's the only question that you're answering. You can stop and you don't have to do the rest of those assignments, right? Because we're never reassigning s's or y's to anything else. Okay, and so that was the answer. Yeah, they are. Yep. I'm gonna, and when this is over, I'm gonna make Pythania stuff visible. I have to wait to do that just because I don't want to waste your time. Okay. Questions and answers. So does that make sense? So this is the kind of question you would see, right? You get a bunch of assignment statements and copies being made, updates happening. When you ask, okay, are they aliases or not? So that's memory stuff. Now let's talk for loops, while loops, nested loops. Cool. Just this one. All right. Find it. There it is. You technically do have to be on campus to view Pythania questions unless you have your VPN set up, but that has been, you can browse or search Piazza for how to fix that, how to get that set up. So, for loops versus while loops. Make this visible. Nope, other one. This one. Okay. So things you got to remember about the for loop and the while loop is that they accomplish the same thing. Okay, they are both used for repeating your some code structure. Okay, so the for loop is best at things that are finite. Okay, so what does that mean? Well, if you have a process that will take an exact number of steps, then the for loop is for you. And classic examples are looping over a list. Right? So if I have a list of numbers, 1, 2, 3, 4, 5, I can write a for loop. Oops. That loops over all of this list. Like so. This one. Okay. So if I go and run this, 1.3 review.py, you see that each successive iteration prints a brand new number. And because the way that the for loop works is each iteration is essentially going to ask, are there more things left in this sequence for me to use in this loop? If there are, then we copy the next thing into our loop variable and then use that throughout the body of the for loop. Okay, this is a for loop by value. Right? We take copies of the actual list. Right? And so you can change this. This could be some list of fruits. We could have apple and orange and grapes even. I bought a something. Okay, it's the same idea where we have our list of things. We're going to loop over this list one element at a time, going in order. So the first value of fruit is going to be apple, and then it's going to be orange, and then it's going to be grape. So printing out some string each time. Right? The first go around it's apple, then it's orange, then it's grapes. So the while loop, right? The while loop is best at indefinite things. Right? Indefinite repetition, as opposed to finite repetition for the for loop. Okay, where you have a little bit more control over how the loop works. Okay, so you're going to say things like, I want, I want to loop over the same list, right? Do the same printing, but all of the stuff that I take for granted, with the for loop, I have to handle them on my own. Okay, so how does that work? Well, I need some kind of variable, right? Something that I can change, that can be a part of the condition that goes next to my while loop, right? What we're going to say here is, so long as the condition that I put here is true, we execute whatever code appears in the body, right, indented one over. Okay, where you're going to do whatever repeated process has to happen, and then you're going to update your condition. Right? So the update your condition part, right? This is why you have to have some kind of variable that you control. You control for this. Right, so to emulate what happens here, okay, I'm going to have an index variable that tells me where in my list am I. Okay? And so long as this index variable, right, because it starts at 0, so long as it's less than the length of this list above, that means it's a valid index, and I should do whatever repeated process I have to do. Right, I can only repeat so long as I still have items left in this list. Okay, what is the repetition that I'm going to do? Well, I'm going to print this. Okay, but the thing that changes here is now I have to directly go into this list at this particular index. And once I've done my repeated process, I got to make sure I update my condition. And so in this case, it makes sense to add 1 to this index because I'm done with this current one. I have to go to the next element. Add 1 to my index, go to the next element of this particular list. And so, commenting out this for loop, just so you can see the exact same output. Over here, right? So it's the while loop that does doing this exact same thing. Okay, what happens when I forget to update my condition, right? Or just don't do that. Okay, I'll go in here. Now I'm met with an infinite loop, right? Or an infinite loop happens because this is always true. Why is this always true? It starts off at 0. We print, I bought an apple. And then because we're not changing index, when we go back up to the top and we say, check this again, it hasn't changed, this is still true. We do the same process over and over and over again until I come in here and hit Control C to force an interrupt, right? Tell it to stop. Hey, I didn't mean to actually do that. Oops. So that's one way. So that's like the basics of for versus while. Right? In for, you're going to do it. You're going to do something a finite number of times. While, you're going to do something potentially an indefinite number of times. You can write a while loop for any for loop, but you can't go the other way around. You can't write a for loop that does everything a while loop can do. And so I'll show you one example of that. What if I want to get user input until something happens? Okay. What if I want to have them print enter open my program, do this. We get some input from the user, and we say let's do enter a name or Q to quit. Okay. So we want them to just keep entering names until they enter Q. Okay. We don't know how many times they're going to enter names, so we can't count that, right? What we should say is, so long as the input that they enter is not exactly Q, then do whatever repeated process we have to do, and then update your condition. So what repeated process might we do? Well, we're entering in names, and so we can just say hello to whoever they just entered. Right? Maybe put an exclamation point at the end. Right? So then we update our condition. Well, what variable is used in our condition? User input. We have to change this somehow. Okay, how would I change that? That's just going to be get user input again. Okay, so how would this work? Well, make this. There we go. So if I run this code, help to actually use the name of the file. Run this code. I've got invalid syntax. Why do I have? Look at that. I'm missing a comma right there. Or better yet, I can concatenate all this stuff just the same. Okay, now I've made that change, saved my code, come back in here, run it again. Look at that. It's letting me enter stuff. Right? Fred, Alice, Bob, Marie. Right? So I will keep entering in whatever I want. Right? It doesn't matter unless it's exactly Q. And the second it's exactly Q, the program quits. Right? The program is done. Right? Why is the program done? Well, we're only looping so long as this is true. And the second user input is Q, this is now a false statement. And so we're done. So that's an example of a while loop that goes indefinitely. And so now let's look at nested loops. Okay, so nested loops, range 5, chain range 5. It'll look something like this. Okay, it's just loops inside of loops. So the thing you gotta know here is how they operate. Okay, it is no different from a regular for loop, from a regular old while loop or whatever. You just have to apply the same looping rules. Could you do an example of while else? The else clause on the while loop is a fancy Python thing, and it won't be on your exam. So, nested loop. So, what's going on here? Well, let's look at it like this. Okay, so if right here is the beginning of the outer loop, right, as I call it. Okay, here is the beginning of sequence of numbers. Right, if I type range 5 and force that to be a list, okay, I get a list from 0, 1 until 4. Okay. So it's a quick way of generating a list of an exact size, so your loop will run an exact amount of times. So this loop will run exactly 5 times. Okay. So this is the beginning of the outer loop. This is the beginning of the inner loop. So where is the end? Well, the end of the outer loop appears right here. Okay, the end of the inner loop is right there. Okay, so what do I mean by the end? The end is the last line in the body. Okay, it's important because you have to know when you're going to go back up to the top. Okay, so what happens when I encounter this code? Well, for I in range 5 says that we're going to loop exactly 5 times through this list, 0, 1, 2, 3, and 4. Okay, so this is a list generated by range 5. We kick off our loop by saying, okay, same as any other for loop, take the first value, put it into I, do the body. Okay, so there might be lines of code that appear here, right? But eventually you hit the beginning of the inner loop, right? Where the inner loop says it's another loop, right? You just do the exact same thing. This range 5 is another list, 0, 1, 2, 3, 4. We do the same process. J takes on the first value of this list, and then we do the inner loop where we say print I and j. So the first value would be 0, 0, and then we reach the end of the inner loop. Whenever you reach the end of a loop, you're not quite sure you're done yet. Right? You have to go back up to the loop and apply its rules. So you reach the end of this inner loop. You say, hey, is there anything left for j to loop through? Yeah, there is. There's still all these numbers, 1, 2, and 3. And so j takes on the next value, 1, and you'll print the value of I, which is still 0, and then j, which will be 1. So on and so forth, right? You keep doing this, right, until you've exhausted all of the values of this list. right? Once you've done that, you've reached the end of the outer loop. You go right after the for loop and say, okay, there's nothing left for this outer loop to do. And so go back up to the top and say, hey, is there anything left for I? Yep, there's still this whole list. And so the entire process repeats, this time with value of I as 1, and then you loop through this whole list with j, printing out the contents of I and j. And so if I run this, you'll see exactly that. Okay, where the first pair of I and j values is 0, 0 here. And the next one is 0, 1, 0, 2, 0, 3, 0, 4, right? You see, for one value of I, we go through all of the possible values for j. Once we've exhausted all those in order, we come back up to the top, I becomes 1, and we go through all the values of j again. And then I becomes 2, and we go through all the values of j. And then 3, and then 4. So what is this telling you? Well, it's saying for the inner loop, we must do that inner loop in its entirety until we can determine if we should go on through the outer loop. And so we might ask questions like, how many times does this print statement happen? That can be answered pretty quickly if you look at the range here, right? For each single iteration, for each single value of I, we must do all of this. So how many times does this go? Right? This says we go 5 times here. So each time we do this, we're going to print 5 times. How many times do we do this then? Another 5 times. Right? So if we do this 5 times, and each time we do this 5 times, you get a total of 25 print statements here. Right? 25 different pairs after the fact. Okay. So I can change this, right? It can change this to 3 and 5, and now I'm going to have 15 total pairs, right? Where we have only values of I from 0 to 2, and the same value of j here. Right? So how do you make it so that the same numbers don't repeat? That would be an if statement inside of the inner loop. Okay, right? Where you want to check, hey, is I and j the same? Right? If they are, I'm going to skip this iteration of the. I'm going to skip this iteration using the continue. Okay. Otherwise, I'm going to print. Okay. So this is one way to do it. If I and j are the same, then do not do the rest of this inner loop. Continue. This belongs to this inner loop. Don't do whatever appears after this. Imagine as if this continue is the new end for this one iteration. We're going to go back up to the top, say, is there anything left to do? If there is, do it. So what does that look like? Run this code. And now, look at the output. None of these numbers are the same. Whenever I encounter something like 0, 0, or 1, 1, or 2, 2, we skip the print statement. Another way you could do this is without continue. Okay, you can put the print statement in here. And what we're doing is we're just guarding the print statement. Okay, we're saying we only want to print if this is true. If I and j are not the same, then print out these two numbers, and you'll get the same output. Neat. Neat. How do you make it so the numbers repeat? Yes, all this stuff will be available to watch later. Yeah. So that's the gist of nested loops. The thing you gotta, this comes with practice, you know. Like if the numbers repeat, like if we have 1, 2, and then don't print 2, 1. That falls into permutations. 1, 2, 2, 1. Oh, okay. I see what you're doing. Okay. So The way that would work would be something like this. Okay, so change that back to 0, 1, 2, 3, and 4. And now, what do I want this body of this loop to say? Well, this isn't going to be, this really isn't going to be a body of the loop problem, rather a change the range problem. Okay, so I'm going to print I and j, and I can actually alter this range to do what you want, right? To change it so the numbers don't repeat. The way that works is I'm going to alter where the range starts. Okay. By saying, hey, start this range at 1 after the value of I won't ever get the chance to repeat any two numbers. Okay. What we're saying here is, only print out pairs of numbers that haven't been seen before. 0, 1, 0, 2, 0, 3, 0, 4, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, and 4. Right. Why does this work? Because the value of I is changing each time, the list that we make here is going to be changing each time. Okay. So in the first iteration, the value of I is 0. So the range that's generated here is 1, 2, 3, and 4. So we're going to print out all the combinations of I and j, where I is 0 and j is one of these numbers. When we reach the end of when we're done with this loop, I still has more numbers left. I will start at 1, and so this list will start at 2, or 1 plus 1, go from 2 to 4. So we'll print out all the pairs where I is 1 and j is something in here, so on and so forth, until we reach the end. The questions are pretty similar to what you see on Titania, what you see on a lab quiz. That is okay. Cool. All right. So that's nested loops. Nested for loops, kind of the gist of how they work. Now let's do the in keyword. So the in keyword is pretty straightforward. Okay, you get a list, just like random numbers in there. Help to use the right assignment. Make a list of random numbers, and I can query this list to see if something's in there. Okay, I can do something like 5 in nums. Is that true? So the in keyword. What other things that people wanted? What else? This is slicing. Cool. Cool. There. 4 print statements. Okay. Slicing is an operation you should know. Given some sequence, so let's say I have a name. We'll just use Fairfax. So slicing, okay, is an operation with these colons. Essentially, you have some starting index, and followed by a colon, followed by some ending index. Where in this sequence do you want to begin making a slice? Where in the sequence do you want to stop making the slice? And so if I say something like 1 and 5, okay, I get this. Start at index 1 and stop at index 5. Remember, this is not a what's it called? Inclusive ending point. So we actually stop at 1 less than this point. We go from index 1 index 2, index 3, index 4. So we take all of those things in order, and we bunch them together to make this subsequence. So index 1 is the A, and then index 2, index 3, index 4. That's how we make that slice, right? If I change this to 4, I drop one of those characters and get just air. Okay. I can change, I can add a second colon in here to change the step size. All right, I can say, hey, go from index 1 to 6 and count by 2. Okay, start here, grab this character, then count by 2. 1, 2 to get the R, 1, 2 to get the A. And we're stopping at 1 less than index 6. So 1, 2, 3, 4, 5, right? Take every other character in that sequence. Okay. For slicing, you got to make sure you're careful. Okay, you can do something like this. Okay, you can do reverse slicing. So start somewhere big. Start at index 6, go down to index 2 by counting by -1. So we do start at the last character, and go all the way down to here. Which means I can do something fancy like this, quick reversal of a sequence, right? Just colon -1. Why does that work? Well, when I write a colon by itself, we saw that gets a exact copy of all the characters. Start at the beginning, right? The default when I says, start at the beginning, stop at the end, and count by -1. So reverse. How many questions is the midterm? We're looking at about 55-ish questions. As a cap. Cool. All right. Print statements. Statements. What does the end equals? Releases. Type this. Oops. 4. All right. Print statements in loops. Transform function, word search function. Okay. So, we'll talk about transform. So transform says we're going to go from a, it's like this, make it smaller. The right one? This one. Smaller. Thanks. Neat. Okay. So transform was, you have a list. Okay. It is some numbers. Okay. And I want to take this, given some number of rows and columns, and transform it into a matrix, right? Now, how would I do that? Well, I have to first have my outer, list. Right? I need some place to put rows in, right? without a place to put rows in, then I'm not going to be able to build my different rows. Okay, let's say I have some number of rows. We'll turn this into 1, 2, 3, 4, 5, 6, 7. Let's make 4 rows and 2 columns. Okay, so the basics of this is I need to step through this list one element at a time and figure out where these numbers belong. Okay, right? I'm essentially just going to be building out one row at a time, right, as I step through this particular list. Okay, so I'm going to loop for all of the rows I want to make. So for each row I want to make, right, I have to build that row. In order to build that row, I need a place to put it. Okay, so I need a new row. Well, how do I build that row? Okay, I'm going to loop for every column, okay, and the number of columns I'm trying to make. Okay, while I am, so what I have to do is then put the next element in the row. Okay, how might I do that? Well, let's keep a track of where we are in this sequence of numbers. Okay, grab the next element by going into this list at that particular place. Take that and put it into my new row. When that's done, I know the next time I do this, right, I'm going to add 1 to my index, right, because I need to move to the next number. When I'm done with the loop, right, what do I know about my new row? I know that I will have put in all of my all the desired numbers into this row. So add that into my matrix. Take that and add it in there. Okay, so I run this. I make a nice go from this, right? 1, 2, 3, 4, 5, 6, 7, 8 by itself to a bunch of 4 rows of 2 columns each. This is one way to do it. This is not the end-all, be-all way of doing it. Index is my tracker. It's my where in my list am I now. Because I need to know what the next number to put in there is. So that's gist of how, what if rows and columns is 3 and 3? Then you would have, right, something break. Okay, so why did that break? Well, for the transform function, right, you also had to solution. You have to figure out if you have a statement in here that essentially says if this index, this counting variable, right, is bigger than or equal to the length of nums. What does this mean? This means index cannot be used to go into nums. then instead, I'm going to add a 0 to this list. Otherwise, I'm okay with adding in nums at index. So that works. And then, of course, up at the top here, you would have something like if rows times columns is less than, is less than length of, what's the thing? Matrix is small, yeah. Length of this list, then you would just, you would have returned an empty list. Right, but I didn't write the actual function, so I'm not going to use that return. That's the gist of what you might do, right? So you have some number of rows and columns that you want to turn nums into. I need a place to put the rows, right? My outer list, my matrix. And so I want to build out all these rows. How do I do that? I start from nothing. A row consists of this number of columns. And what I do for each of these columns is if I determine that my current counter into nums is not valid, add a 0 to the row. Otherwise, add the next value from nums into the row. Increment my counter to say, hey, you did something. Move to the next index if you have to. Once this whole loop is done, right here, that means I now have a full row. I should add it into the matrix. This might not be the end, the finish point, right? You go back up to the top if there's more rows to build. You start with a brand new one and do the same thing. And so at the end, you get this output. All right. So for the main thing to note is you have a guaranteed word size. That comes into play because essentially you're a hint to use slicing, okay, to build all the words. Okay, so what might that look like? Let's say I just take these examples from the PDF. So I have a puzzle, looks like that. I have some words, it looks like that. Okay. So my goal is to find the words from here that appear here forwards or backwards. Remember, this is a word search, and so you can kind of think about it as if I'm lining them up like this. Okay, so I'm trying to find car, 10, end, and arm. See if I can find car. Nope. Oh, look at that. Car is vertical, so I don't have to worry about a car. Right? Car I'm not going to find. It doesn't appear forwards or backwards. What about 10? Nope. 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 Oh, look at that. There's 10. All right, just spelled backwards. So I'm going to have to make sure I find backwards words. End. Look at that. It appears right there. Arm also doesn't appear horizontally. It's vertical. So how do I do this? Well, first things first, I am going to see if I can build all of the words, right, in one of these rows. Okay, so let's say we have row 1 is just puzzle at 0. Okay, I know that my word size is going to be some fixed number. Right, that's one of the assumptions. My word size, I can just take the length of the first word from this list of words. Okay. How might I build all of the possible word candidates in the single row? Well, you have to go forwards first. So for each index I, right, in range length of the row. Okay. What I'm going to do is I'm going to use slicing to print out all of the different words that appear forwards. Okay. So let's print from the first row, start at index I and go until this word size. Go until I plus word size. This will give me all the characters from this starting point until this ending point. This slice is going to be exactly word size characters long. Right, if I print this out, oops, I'm going to comment these lines. Right, if I print that out, I get CFT, FTO. I get a little bit extra, right? I get CFT, I get FTO, that's good. But what I want actually is, I don't want these words that are too small, right? And so I can actually adjust my range to stop, right, once I reach a certain point, right? So once I reach, when do I want to stop? I want to stop the last time that I can make a fully sized word, right? I want to go make this, it should work like this, minus word size. Yeah, like plus 1. That works. Cool. So I adjust my range to only give me valid indices that let me make all the words in one direction. Right? So if this is my forwards word, okay, I can just print that out for now. So I know how to I can find forwards words now. Let's see if I can find the ones that go backwards in the row. Okay, I'll do another for loop. Range. Right, it might look something like this. So this time I want to get the backwards word. Okay, that's going to be some kind of slice. Backwards word. Okay, so right now, right, this just finds the forwards ones because I haven't told it to do anything else. Right? I have to figure out how to adjust my range and how to adjust my slice to get it to go backwards. Okay. So -1 is the index of the last character. And if I went to the minus length of the row, okay, what I would see is this. Okay, printing out all those values. Of course, you have to count by -1. Okay, I get -1, -2, -3. -1 will give me all the valid indices in this particular row, right? -1, -2, -3, -4, because there are 4 total characters in the list. So what I want is to build a slice, right, based off of I, right? I want to go from this particular place, right? From I to I plus word size. Let's see, does this one, let's just see if it works, having not adjusted the, yeah, okay, cool, it doesn't work. Okay, so Okay, so I have to change this somehow. Okay, I need to start somewhere else and end somewhere else. Okay, if I start at I, okay, I see that I get that OTFC, right, which is this character starting from the back. Okay, so I could, right, just say start at I and then go from start at I and then go to I plus the word size again, but I have to change how I count that. Right, I have to go -1. It doesn't work. You know what would be a better way to do it? Okay, I'm not looking at my reference solution for this, so forgive me. Right, I think was this just brought up? A better way to do it is that I know how to do it forwards, right? And so I also know how to do how to flip a word, right? How to make it go in reverse, right? So all I have to do is take my row, right? Take my row and make it backwards, like this, right? Row 1, colon, -1. Then all this stuff will work for this backward row. So if I replace this, oop. Yeah, that'll work. Oop. Yay. The even bigger brain moment you could have would be once you have your forward word, right, you can just flip that too. Right? CFT, FTO, OTF, TFC. Yep. Cool. So now I have, I can find all the words in a single row. Right. So now find some backwards. Now I can take this logic and apply it for the whole puzzle. Right. So what I'm going to do is I'm going to say for each row in the puzzle, all this stuff has to happen. Right? Or instead of using row 1, you just use row. Right? Find the forwards word, find them backwards, and then you're done. So if we run this, right, now I have all the possible three-letter words that appear forwards and backwards. Okay. What I'm going to change instead of printing is I'm gonna have to determine if the word is one that I'm looking for. Right? So if this forwards word is in my list of words, okay, I have to do something. I have to keep track of which ones I found. Okay? I'm going to put it into my found words. Okay? But I have to make sure that I don't add any duplicates. So it's not a question of getting rid of duplicates. It's actually making sure that the word is not in there to begin with. So if the forwards word is one that I'm searching for, and it's not already been found, you're allowed to include it. You're going to do the same thing for the backwards words. And you're going to take this, and do it for your backwards words. Where at the end, I can find all my words. End in 10. So this is not meant for you to like get off right off the bat. Okay, really, this is by no means the level of problem you'll have to do on midterm. Okay, you should take away from that really the process that I kind of just went through, right? I took the smallest part of the problem, which was finding a word in one way, and figured out if I could do that. Once I did that, right? Once I had that part working, I took that and tried to apply similar logic to a different, smaller part of the problem. Find the backwards words. When I got kind of tripped up, kind of couldn't remember how I did it, I thought for a little bit and said, "Oh wait, this looks a lot like what I just did. If I just change how it looks a little bit, make the word backwards, and then you're good." All right, you can find it just like you found them going forward. All right, and then I took that, right? I took what I had done. I can find the words forwards and backwards, and I just applied that to all the rows in the puzzle. Right? Increased my complexity. Right? I start with simple, then went to complex. Once I did that, it was just a little bit more tweaking to actually start finding words. Zigzag function on homework 3. What did that one look like? Zigzag on homework 3. That one was, you have a string, right? And so you check forwards and backwards and append the word that was in both of them. I check forwards and backwards, and then only append the words that haven't been found yet. So the zigzag function was, you had a string, right? And then you had to alternate back and forth, right? You had to go one at a time to build a brand new string. So how did I do that one? This one is another looping problem. Okay. For this one, I want to go for exactly how many characters there are in this string. So I'm going to use range length of this string. Okay. But the neat trick here is you might not be necessarily dependent upon I to tell you what exactly to print, maybe. Okay, because it was every other iteration you're going back and forth, right? So it would be A, use A first, then G, then B, then F, then C, then E, then D. If you look at this, right, that's essentially every other iteration, I'm going to do something different. And because we're using every other, that's key to check for the evenness of I. Okay, if I as a number within this range, it's either going to be even or odd, one or the other. So I'm going to do something different depending upon if it's even or if it's odd. Okay, I'm going to put a print statement in there if just for placeholders for the structure. So I'm going to do something here if it's even, and something else if it's odd. All right, I need to build my new string. I started off from nothing. Okay. So what do I do here? If it's even, I need to grab the next character from the left. Okay. So what I'm going to do if it's odd, I need to grab the next character from the right. And so I'm actually going to keep two different numbers. Okay, left and right. Right. This tells me how far on the left or how far on the right I should advance. And so if I'm at an even step in my process, I'm going to be on the left. Right? And so I should print the character in this string at the left index to see if I'm grabbing the right thing. Right? And when I'm done using that character, I'm going to add 1 to my left index because the next time I'm at an even step in I, I'm going to be at the next character on the left. And I'm going to do something very similar with the odd step. Right, where I'm going to print using the right index that I'm checking. Right? So let's see what that did. That. Okay. A, G, B, A, C, B, D. Uh-oh, not quite right. What happened? Okay, starts off at A, that's good. Then G, that's good. Then B, that's good. Then A, that's bad. Oh, so I updated this incorrectly, right? If I'm starting off as the negative index, I should be subtracting 1. Right, not adding 1. Subtract. And now, A, G, B, F, C, E, D. A, G, B, F, C, E, D. Cool. And so instead of printing, I'm just going to add, or concatenate, this specific character. Such that at the end, I have my brand new string. Boom. A, G, B, F, C, D, E. Nice. Done. All right. Oh, I've been on for like 2 hours and I haven't eaten lunch. Okay. I'm going to go do that, I think. Cool. So for any last minute questions before I get off? I will be posting this, like this. You'll get a link to this on Piazza. You can stream through, and I'm gonna do another one tonight, 8 o'clock. Probably that one will probably be problem centric. I think. Try to come up with some sample problems. Whoever your lecturer is will grade your midterm. Review tomorrow will be, if you are in my class, I'm going to be doing review in that lecture. Yeah, I'm going to unlock Pythonian questions before I leave. Do you think we should practice? You should go back through your lab quizzes and recognize find any of the mistakes that you might have made and figure out how to fix those, or note what you did wrong there so you don't do the same thing. Go through Pythonian questions. I'm going to unlock those for my classes shortly. Other than that, going back through kind of that list of topics that's available, skimming that, and focusing on the parts that you're not as comfortable with. finding problems in the book or finding problems in the slides that are relevant to that. Will help tremendously. Yeah, those iBooks challenge questions are similar, right? In that they test one specific idea. There's usually not a lot of code. All right, so I'm going to go ahead and end the stream. The midterm, if you're not going to join again, or if you don't have class tomorrow, remember your midterm is Wednesday and Thursday of this week. So if you have class with me on Wednesday, then that's when your exam is. If you have class with me or with Professor Snyder or Professor Dimitriadis on Thursday, that's when your exam is. Okay, so remember your exams are in class. Okay, they are paper and pencil only. Okay, come with your GMU ID. You need that. If you don't, we might not be able to take your exam just because there's a lot of people. So remember that. Cool. I will maybe see y'all later if you're in my class. If you're not, maybe I'll see you in office hours. I don't know. I got a nice office. It's pretty neat. I got lots of Rubik's cubes and a jar of candy. Try to bring your GMU ID, but usually state ID is okay. All right. Have a good rest of your day off.